In this lesson, I will finally get around to talking about the hardware needed to run the Seismic Terrain Explorer. I started talking about the subject 2 lessons ago, but I decided that since the Explorer is so intimately tied to the graphic card, that I would expand the subject and talk about why the Explorer is so graphics intensive. Hopefully, by now you get the point, and understand why you can't run the Terrain Explorer without a good graphic card. In saying that, I don't mean the best card on the market. My main machine, for example, runs with an NVIDIA 1080 GTX, which is about 3 years old. So you don't need the best card on the market, but you do need a good one, otherwise the Explorer might be slow. It will still run, but it might be slow. So in this lesson, we'll get back to what is required, and specifically, I will talk about why it requires an NVIDIA graphic card. That is a different subject, because NVIDIA isn't the only company that makes good graphic cards. ATI, for example, also produces high-end graphic cards, and if the Explorer only used the GPU for graphics, then ATI would be fine. But as I'll show you, we don't just use the graphic card for rendering, we also use it for processing and accessing data, and for that we use an exclusive NVIDIA technology called CUDA. Let me show you one of the things that we use it for. The project that I will use is this one. It is the New Zealand Kerry 3D, located in the Taranaki Basin, and the data is courtesy of the New Zealand government. I'm using this example because I have 2 different versions of the 3D. The first is this one, the raw migration, and the second is this one, the semblance. What I will do is put them together in a rather unique way and show you how we can animate through this display using subsampling. The first thing I want to show you is just what I talked about, subsampling. This is a time slice starting at, I believe, 856 milliseconds. Normally, if we animated through this volume, we would animate at the sample interval or greater, which in this case is 4 milliseconds. I'll do that now. As you can see, the animation is jerky, and I think it leaves a lot of information behind. One of the points I make about sampling is that all we think about is capturing the required frequencies and wave numbers. What we never think about is how to reconstruct the wave field, or even how to best animate through it. In this case, I'm going to animate through the 3D at 1 millisecond. As you can see, the animation is much smoother, and if I were working with this data, this is how I would want to work with it. As I said earlier, I also have the semblance volume for this 3D, and you can see it here. We can animate through it just the same way we could animate through the amplitude data. But we can also do more than that, because we can combine both the amplitude data and the semblance data together in various ways and produce displays like this, which we can also animate through. So what is the point? What has this got to do with hardware? Well, as I said earlier, if all we were concerned about was the graphics in the display, then you could use either an ATI graphic card or an NVIDIA graphic card. But what I have just shown you is a subsample animation through 2 large seismic volumes, the amplitude and the semblance, in real time. The only way that you can do that is with parallel programming, and I use parallel programming for this and other things all throughout the Terrain Explorer. The language that I chose to use is called CUDA. It is an industry standard, it was developed by NVIDIA, and it runs exclusively on NVIDIA hardware. So obviously, to run the Explorer, you need a relatively modern NVIDIA graphic card. But after saying all that, I don't want you to think that you must go out and buy a new state-of-the-art card, because it's more than likely that you have other geophysical software that will almost certainly be using CUDA itself. So, after 3 successive chapters on hardware, the conclusion is that yes, you need a good NVIDIA graphic card, but you probably already have one, and it will probably work just fine. Could probably have said that a bit quicker.